All right. Okay, so if you see the plan for today is the following. Go over the old assignment quickly. Just you tell me your probably your what you got as answers. We still have data analysis part 2. So I was actually thinking, and I want us to do projectile motion today. So I was thinking, shall I do both or should I do one? And then I realized if we do projectile motion first and we see how it goes, if we have a bit of time, probably we can start data analysis part 2. All right, because as you know, the data analysis we did is only one big part of what you should know in data analysis. All right, and I want to take time with data analysis. Meanwhile, I want you please to turn your cameras on, at least for the first 15 minutes. If you want, we can go to Blackboard. Let me see. I wish I had it ready, but I don't have it ready. Probably see if you submitted the assignment and we're waiting a bit for students to join. Yes. Let me see our class, and probably I can fetch the list of users so I can have a list of your names. Yeah, thank you for turning on your cameras. Tomorrow's sections don't have class. Could it be assignments like that? So let me see. So it shows that a lot of students did turn in. Submit here. Wow, everybody did turn in, right? Except Aya, for example. And Aya, it's okay, you still have time, do it. All right, is Aya with us?
Yes, I'm here, doctor. I didn't know that we needed to submit it. I actually did the homework.
Yeah, no problem. I usually use the first assignment for us to get used to the system, you know. So now you know. And again, this is not graded, so it's only for us to get used to the whole thing. All right. So if you need any help, technical help, I mean, because I know probably you don't need actual help, let me know. So we're 20. So far, we are 17 students on WebEx. So I say we start. Let me keep your names close to me and let me go with the plan. So correct all the assignments. Your assignments are already here. Probably you can tell me what you got as answers. So let me see. Assignment due. This is your assignment. So let me open it with a special app so I can write on it. All right, I'm not going to correct the first slide. It's easy. If you want, the answers are the underlined values. So for example, this is 5 and this is 5. And we already did this in class. If you're not sure about it, you can check in the recorded video, okay? Now, probably I can ask our dear friend Fadi. Fadi, can you help me giving me the answers for this one? Yeah, so we need the answer for this one. Let me probably type it. It's so much easier. No answer from Fadi, probably Sarah. So the length is equal to. Any answer from Sarah? Yes?
I got 4.3.
Okay.
And the uncertainty is plus or minus 0.25.
0.25. All right, would you like to add anything?
The unit.
Centimeters. Centimeters and this centimeters. All right, now let's go back to the theory. It states that the smallest subdivision divided by 2 is our uncertainty. Smallest subdivision here is 0.5, divided by 2 is 0.25, but it has to be rounded to 1 sig fig, so I'm going to round this to 0.2 meters. And then I'm going to look, this is 1 decimal, I mean centimeters. This is 1 decimal, this is 1 decimal, so we can keep it as such. So back to you, Sarah. This is not wrong, but make sure you round your error to 1 sig fig. Any questions related to this one?
Doctor, I added a 0 after 4.3. Is it wrong?
All right, so you added a 0. This shows that L and your error, they have the same precision, which is good. But how about we round the error to 1 sig fig first, which means we don't need the 0 anymore.
Okay.
All right, so your method was actually okay. Your only mistake was not round the error to 1 sig fig. So let me see. The question is, can it be 0.5? Charles, actually, the smallest subdivision is 0.5. We need to take half of it. So no, it cannot be 0.5. Yes, 0.3. If you say 0.3, it's not a big deal. But usually when we round, it has to be even odd when we have a 5. So if I have a 5 and I have a 2, I keep it because it's even. That's why no need to round up to 3, only because you have a 5. Let's say you have 0.26. Yes, you round to 3. Let's say you round to 3 by mistake. It's okay. It's I don't think we should make a big deal out of it. Probably ask Michael now to do the second example. The example of the scale. So Michael, we need the mass.
Yes, it's 126.4 pounds.
Okay, 0.4 what? Pound. Wow, you saw it, LB. Okay. And the uncertainty is?
0.1.
LB. Perfect, yes.
LB.
Yes. Now let me see if I can see this one because it's barely visible. Just a second. Yeah, can I see it? Oh, it just happened. Okay.
Doctor?
Yes.
Is the uncertainty always 0.1 when you have a scale that measures like 1 decimal place?
Yeah, exactly. If it's digital, you mean.
Okay.
All right, so now we can pick Priscilla, please. Priscilla, I want you to help me with temperature. What temperature did you write? Priscilla's with us. All right, so Ellie, so 0.35 would be 0.4, that's true. Priscilla's not here, probably Jane can help. So Jane, your answer would be?
Yes, doctor, I'm here. My answer, sorry, I didn't check because I submitted it, but I can do it now.
Yeah, no problem.
It's so 33.00 plus or minus 0.25. Okay. No, 0.5, sorry, so it's 33.0.
Smallest subdivision is 1 divided by 2, 0.5 degrees.
0.5, yes. The degrees is 33.0.
Okay, fair enough. What if somebody would say 32.9? I think it's okay as well, right?
Yes, feels more.
Yeah. Let me see, yeah, for it to be visible. All right, the next. Okay, so I hope you have the answers for this one because for us not to waste time, probably I can ask Christy for this one. So Christy, what average did you get and what is the error on the average?
38.02 degrees and the error is, just a second, 0.07.
So you said
38.02 and the error is 0.07 degrees.
Okay, the error is 0.07 degrees. All right, people, do you agree with this one?
لازم تكون صح.
All right, so I believe if it's working okay with most of the people, it's gonna be right. If you don't agree, just speak up. All right, for this one, I would want to discuss it a bit now that I had a question from some of you. So let's write the answer and let's show how we derive the error. So our job is to find R. Probably Anthony can help me. So how do you find R? Anthony? Hi, Matt. Hello, Anthony. Fadi? Yeah, so obviously, Fadi, your microphone is not working because we can hear a weird, very low frequency. Yes, it sounds funny, but I know the microphone is not working with you. Can you type, please, Fadi, on the chat so I can read you? Meanwhile, Anthony probably can speak up. Yes, Yara, go ahead. Yara, yes, what's the value for R?
158 0.42, approximately 200.
Okay, we're talking ohms, right? So you use 3.2 divided by 20.02, which is also divided by 1000. And what error on R did you get?
4.5 approximately 5, so 200 plus or minus 5 ohms.
Is it 50?
50?
No, say it again. I couldn't hear you.
200 plus or minus 5.
5, okay. So you got 5 for the error on M. This is where on R, this is where you decided to round your R.
Yes.
Okay, I can see that you should remove all your decimals, right? Can we round this to 158 ohms?
Yeah, we can, بس نحن ما بدنا one significant figure للerror.
No, we need one significant figure for the error only, but not for the actual calculation. So the actual calculation should be similar to the error in number of decimals and not in number of significant figures.
Oh, okay.
All right. You know, I'm happy to see those tiny mistakes because, however, like for example, if I don't see those mistakes, like this is the only way for me to be able to see them. All right. So now, how am I going to do the error on R? Let me see if I can fetch any document because I hate to write on this app. And I'm sure that at least 50% of the class will not be able to find the error on R probably. So let me use it in here. So to find the error on R, don't you have R to be equal to U over I, right? And I can take a screenshot in a moment to add it to our document. So to find the error on R, I must do derivative. I'm gonna write regular derivative. I know this is mathematically not correct because I should write a partial derivative. So derivative of R with respect to U times the error on U. All of this is gonna be squared, okay? Plus the derivative of R with respect to the other parameter, which is I, times alpha I, all of that squared as well. And I'm gonna do the square root for it to be, yeah. And then what is the derivative of R with respect to U? It's gonna be 1 over I. Okay, so Imad, probably you are the one who asked me this, right? And the, yeah.
Yes, sir.
And the derivative of R as a function with respect to I, so imagine you have U over X, which is minus U over X squared. So minus U over I squared, which is all of it multiplied by alpha I, okay? So here you just have to plug in the values. For the students who already did that, this is what you did?
Yes, doctor.
Okay, what about you, John? John, would you like to speak up? All right, the other method, all right, I see. And did you end up with the same answer? All right, fair enough. The other, basically, if you, yeah, you will end up with the same answer. I'm gonna keep that on my screen to send it to you along with the answers to this one. Shall we move on? Are we done with the assignment? I suppose we are, unless you want me to go back to anything to check it out. So we're done with doing that. Do we round the uncertainty according to the answer's significant figures or the other way around? We actually round the error first, the uncertainty first, then we round the value accordingly. So we round the uncertainty to 1 sig fig, then we look for decimals and we round the measurement accordingly. So the measurement and the uncertainty should have the same precision and therefore the number of decimals. Is that confusing for you, Fadi? Cool? All right, so now—
Can we use the analytical method, the analytical CAM method for the
of course
for the error?
Of course we can use, and I suppose you should get the same answer. All right, and if you're not getting the same answer, you have to let me know. All right, so let's keep data analysis until later on, and let's start with the actual experiments. So let me see. Let me discuss basically projectile motion, and then we can watch the video. The video was taken in the fall of 2020. Obviously, because of the lockdown, I couldn't go to campus to create another video, but I think and I hope the video will be clear enough for us. So projectile motion, I'm gonna go over the following. What is projectile motion? So basically this is something you're supposed to know from middle school or probably from grade 11. Kinematics equations, what are they and how we apply them to projectile motion. The velocity vector, how can I describe it during projectile motion. Eventually the rate, the range and height, and this is what you really care about for the experiment. And what happens when we add air resistance, okay? So you tell me, what is projectile motion? How do you define it? So projectile motion, how do you define it?
هلا projectile motion هي مثل الفري فول بس فرق انه الموشن هي in 2 dimension يعني we take the x and y into consideration نحن عم نشتغلها.
All right, similar to free fall, 2-dimensional. Gravity is the only force Priscilla is saying. So the only force acting on it is the force of gravity. The initial velocity, anything about it?
بيكون عندنا initial velocity.
So the initial velocity is either along the x or either along the x and y, and that's why you will have two components and eventually 2-dimensional motion. So I found this definition which says exactly the same thing, and it also says that you can divide it to simultaneous independent motions, okay? So 2-dimensional motion. So what I care about is to say not only 2-dimensional, but obviously, and let me, since the slides are big, so they are two independent motions and simultaneous happening at the same time. You can see here, if you want, the initial velocity, it is at a certain angle alpha. You can see the parabola. And for the force of gravity, you can see that the force of gravity is basically the same everywhere throughout the motion. And this is the only force acting on your system. Since the net force is equal to ma, that's why the acceleration is also proportional and pointing in the same direction as the net force, which is the force of gravity. All right? Yes, Imad, you have a question.
دكتور في شيء ما فهمت انه كيف ببروجكت في عنا بس وان فورس، عنا ويت وعنا الفورس اللي نحن عم نطبقها في resistance.
All right, your question is basically legit. The weight is actually the force of gravity. Do we agree on this?
Yes.
Air resistance always exists, but throughout this PowerPoint, we're gonna discuss as if air resistance is not taken into account. And all the equations we're gonna use are not applicable anymore if we have air resistance. But if we do the whole study, there is a way to add air resistance to your equations probably after we're done. And please remind me if I ever forget to do that. Now, concerning the initial push or the initial kick of the boy, this is an initial velocity and not a force, which means that the force of the kick is only there for a fraction of a second at the beginning of the motion. And no, this force is not gonna stay with the system throughout the motion, so you cannot take it into account. It will only provide you with an initial speed, and that's it. All right? Initial kick is always a confusion for a lot of students. I would like to talk a bit about both motions. The first one is uniform, the one along X, and the one along Y is uniformly accelerated. All right, this is very important. So the motion along Y is very similar to a regular free fall. The motion along X is simply a uniform motion where you have speed is distance over time, you know, but I'm talking about the X component of the velocity. In the next slide, I would want to take more time discussing the kinematics equation, which means this is the general scheme. Have you ever used these equations before? Yes?
Yeah. Yes.
Yeah, definitely, because this is very important to do any motion problem. وهلا عم نعملون. Okay, so T represents time, A acceleration. This is basically applicable only if you have constant acceleration. V0 is the initial velocity, because probably your teacher is using different annotations. Delta X is the displacement. Probably you know 2 or 3 of those equations. Probably you don't know them all. Yes, don't worry, Layla. So these are general. Now I'm gonna write those kinematics equation for the x component and for the y component. And probably somebody can help me, maybe Karel. Karel, let's write those for the x component, okay? So anything would you like to modify? Like x is gonna stay x. Let me start with A. Do you have, Karel, any acceleration along the x-axis?
Along the x-axis, there's no acceleration.
So I have all the happiness of removing this and this and this. And now my equations are so much simple. I have V equals V0, meaning my V is uniform. V squared equals V0 squared, meaning uniform, which means I'm not gonna use those. This basically means VT, which is distance, speed times time, or velocity is distance over time. I'm not gonna use this. So the only remaining equation that makes sense is this one, which is delta x to be V0 times t. But I'm not gonna use this V0. Instead, I want to use the x component of it, which is V0 cosine theta. Okay, so what you can take from those is only this one. If you, on one condition, you have to replace V0 by V0 cosine theta. Okay, so now let me check these. It says x initial is equal to x0 plus v0 cosine theta. If I take this to the other side, it's gonna become x minus x0, or I can simply replace this by delta x, okay? So you can keep this with you as we start now with the y direction. Probably I can ask Sarah again. Sarah, let's live with those kinematics equation and try to write the y components. Okay? Fine, so Sarah and I were doing the y equations for the kinematics. What do I replace A with?
G.
Yeah, let me do it with minus G
A.
because minus is gonna be downward. V0, what do you replace V0 with?
Do we keep it the same thing?
We replace it actually with the vertical component of V0, which is V0 sine theta. Okay, so let me write it as V0 sine theta. Now for delta x, what do you want to replace delta x with?
Delta y.
All right, anything else? So also V can be replaced by V sine theta, okay? Or probably keep it Vy because V is not known anyway. So I'm gonna replace V by Vy. Let's not keep it V. And later on, when we find Vy, we have all the time to replace it by the actual V sine theta. So let me see what they did. They replaced V0 by V0 sine theta. A was still A, but remember A will be negative G eventually. This is delta y. V is replaced by Vy, and V0 is replaced by V0 sine theta, all right? And this is delta y, obviously. So probably you think these equations are not so clear because I can see they're not very user-friendly. However, you can use any equations you have from the course. Just keep in mind, we started from random, like very easy kinematics equations, and we applied the definition of projectile motion for the x direction and for the y direction. So now I have two equations that are, two sets of equations that are independent and separated. The only common term between those two is, what do you think? What's common between the two sets? Anyone?
Theta, the angle.
The initial velocity.
Interesting. Yeah, I never thought about it. Theta is the only, is one thing that is common between them. The initial velocity as well, like V0, but there's something very important. Because
the acceleration?
No, because I don't have acceleration along x. Yes, time. Thank you so much, Karel. Time. Imagine what's happening along x and what's happening along y. It's happening at the same time. And this is what I wrote here as simultaneous, happening at the same time. I love this word and it's very like sharp. So basically, if you ever find time from those equations, you can use the time for those equations. We're going to play around with these equations whenever we reach range and height. So far where we are, we did this one and this one, okay? Very soon, we need to use the kinematics equation to be able to discuss range and height. Now velocity vector. So those are still with me. What you need to know, and this is something that we already discussed, on the horizontal axis, you see the behavior of V. Anybody can describe the behavior of V? Just speak up. Probably I can ask.
Vx is constant.
Yeah, this is very important. It's not changing.
No acceleration.
No acceleration. Vx is pointing in the same direction, same magnitude. What about Vy? Anyone?
ما عنا في تحت بلا عنا في
Okay, so you see Vy is a vector that is getting shorter and shorter and shorter, and at the top of the motion it's gonna disappear. Then it's gonna become downward and then getting longer and longer and longer. So this is free fall basically. So you slow down to a stop and then you speed up down as you go down. So this is like the shadow on the wall, and this is the shadow on the X, and projectile motion is happening anyway. All right, quick reminder, V can be broken into Vx and Vy. Now, if we need to draw them all on one axis, this will become a bit hectic, but it's very interesting to see. You see, Vx will have always the same length. Even this is Vx. No change in length for Vx. However, Vy starts being long and then shorter, shorter, shorter. No Vy here, you see it disappears. Then it's gonna flip downward and it's gonna become longer and longer and longer. Let's say I have Vy like this and it's given, and Vx like this and it's given in magnitude. I know its value. How do you find the actual V, which is the resultant? Anyone?
It's radical Vx squared plus Vy squared.
Basically, you do the Pythagorean theorem. Awesome. All right, so you need to have to be like ready to play around with those equations. I know you do a lot of this in the course, not a lot on the lab. In the lab, you just need to understand the concept more than how to deal with the calculations. And sometimes concept is difficult to grasp if you don't understand the theory well. So range and height, let me start with the definition. What is a range? The range is the distance between the shooting point and the landing point. Some people call it is the horizontal whatever range, distance, displacement. The maximum height, or the height, I mean by height, the maximum height, you take the maximum point and you measure the height for it. I need some help in the following. What's interesting, let me call this point A and let me call this point B. What's interesting about point B? Something special that happens at point A, I mean. Anyone?
Velocity zero.
Basically, no, velocity is not zero at all. Probably you meant Vy, exactly like what LD, Christy, and Noha said. So Vy is equal to zero. Remember, at the top of the motion, the projectile is still moving forward. So you have velocity forward. Vx is always there. So only the y component is zero. That's for A. What about B?
y equal to zero.
Exactly. I can see a lot of answers in the chat. Y equals zero because simply you are on the ground, and this will help you a lot. Let me go back to the kinematics equation. By the way, you can keep, to be honest, I don't like delta x and delta y for projectile motion. I'd rather take my initial x to be zero and my initial y to be zero and play around with x and y because it's easier on my x and y axis. So by saying y equals to zero, I can replace this by zero and I can solve for t, time. And finding the time, I can find x, which is my range. All right, and to find the height is basically replacing Vy by zero. Then I'm gonna find the time and replace it in the y equation, which is the height now. So height is basically calculate the y when Vy is zero. And the range is calculate the x when y is zero. All right, because you will be asked in the lab report that I'm going to show you in a while to derive the equation of height and range. They are given to you, but you're supposed to derive them. By the way, this is how they look like. This is general. It shows you initial velocity. In some books, they call it U, meaning initial, angle theta. The range is called S here. You can call it R if you want. And H maximum, you can call it HM. So they give you the time of flight or the time taken to do the whole thing. You don't need it for the lab. No, this is to the apex. يعني to the maximum peak. The total time is this one. The range to the apex, you don't need it. The total range is what we need. The maximum altitude h is what we need. And it's also written in the manual for you. Now, before I go to manual and lab report, I would want us to discuss a bit air resistance. And you can see that my slide is empty because I need your support and your input. Let me show you something before I start asking questions. Undo, yeah, all right. So I'm just simply drawing y versus x. That will show me the trajectory of my projectile. And so far I know it's gonna look like this. By the way, make sure you start the x and y axis from the starting point of the motion. Like for example, if you have a building and you have Superman or probably Christie jumping off the building, take the x and y to start from the starting of the motion. Okay, don't take x and y on the floor, because if you do take x and y on the floor, you need to take your initial x, like in here. Didn't we assume initial x to be 0? Yes, so we cannot do that anymore, and the equations are going to be a bit different. So for us to make our life so much simpler, take the y and x to start from the starting of the motion, and I'm going to do this in the lab. Now my question for you is, how do you think this graph will look like if I add air resistance? That's the question.
I think it would shrink, so it didn't go that high or go that long.
All right, so Andrew believes that the y and the x will be affected. So the height is gonna be smaller and the range is gonna be smaller, and you're gonna end up with something like this. All right, so air resistance is basically a force, isn't it? Let me call it Fr to represent friction. Does it affect the x or the y component of the net force, or probably both, according to you, Andrew?
It's primarily affects the y, بس أكيد consequently إذا الy قلت ساعتها it will reach the نقطة تبع ground sooner, making the range less.
I don't agree with you, Andrew, because y and x are separated, right? They're independent, even if they're happening simultaneously. I would go more with Fadi's answer, which is friction is not horizontal, it's not vertical, it has both components. So imagine I'm the projectile flying. I would feel wind horizontal on my face, and I would feel wind vertical as well. So we can simply break friction into two components, x and y, because y will not affect x. This is what I don't agree with. You see, Andrew? So if I have friction along the y only, x will not be affected. All right? So Priscilla, basically, if you want the friction not to affect x, this has to be your given for the problem. So I'm going to start the problem now, like a thought experiment, where I have friction, and I'm going to take the friction on x and on y. All right? Which means if I take net force is equal to ma, all right, I'm going to do this along x and along y. Okay, so along x, initially I had no net force. Now I have friction and it's opposite to my motion. So I'm gonna say minus Fr to be equal to ma. And now A is gonna be the x component of A. So what I'm trying to do here, and I can see the choice of pen was not a great idea. I'm gonna take net force is equal to ma. Initially, let me show you how it was. Along the x, we had no net force. Initially, meaning without a resistance, and along y we only had the gravitational pull, which is minus g for the acceleration. Now I'm going to simply add a negative Fr for the force and a negative Fr for the y force as well. All right, so for the x component, no, I'm not going to take the weight, only for the y component. And here you are right, I'm going to say it's an mg minus a different Fr. How about we call it Fry, and here I'm gonna call it Frx. And this is equal to MAY, okay? So I'm trying to help you start with a starting point. Initially, and let me remove this one, it's bothering me. So initially I had this equation, net force is equal to MA, fine. How about I save as a copy only for us? And let me call it something, projectile motion for the Monday section only. What did I just do? Okay. All right, so basically, this is how we start the motion. By the way, this is a vector equation broken down into X and Y. Initially, where I had no air resistance whatsoever, the net force was 0 along X. It was only there along Y. So the acceleration is 0 along X. And the acceleration along Y was negative G due to the fact that the net force was mg, or negative mg because downwards. All right, which means this should be negative and this should be positive. Now that I have friction added to my system, friction as I move forward, friction is opposite to me. So I need to add to my net force an actual friction. And as I'm moving forward as well, mg is downward, friction is against my motion, which is downward, so it's upward. So it's like I have two frictional force, one along X and one along Y. Now what you can do is the following. You can simply decide to remove friction along X. Isn't it a model we're building anyway? So a model is your choice. What is reality? For me, reality should not be exceptional. Why not take friction along X and Y? But you can simply say, let's assume friction along Y only, or let's assume friction along X only, but I don't see why we should have this one and not this one. So if we need to go back to this one, now you have an acceleration along X that you can find, and you have an acceleration along Y, and you can go back to your kinematics equation and write them again, taking into account AX to be related to the actual friction and AY to be related to the actual friction, all right? So I know I just gave you some ideas with no virtual ending, so I did not give you an answer, I know. Just some thoughts for you to think about in case we need to add friction. What does it affect? Obviously, it's gonna affect the net force. And we have the choice to take friction along X or along Y or on both. And keep in mind that friction is against motion. So if I'm moving forward, friction is against me. Moving downward, friction is against me, the X and Y components. And then modify your net force and find new accelerations along X and along Y. Yes, since now I cannot cross out the M's. This is what Priscilla is probably saying. I cannot cross out the M's. I cannot say the acceleration is negative G or something. It's gonna be mass dependent. So the heavier the object is, the more the acceleration is gonna depend on that. Actually, I have a virtual simulation and we don't have
أنا كمان دكتور حسب كمان السيرفيس اير تبع الاوبجكت كمان بتاثر فيها الريزستنس فمش شايفين لحطينا.
Thank you so much. Thank you so much. Thank you so much. So what Imad is saying, the size, when I call it the size, you can deal with a small ball or with a big ball. I mean the size would affect it. So this simulation I have, probably I can share it with you. I'm gonna write a note about that. It actually, you can add a resistance to your projectile motion and play. You can add mass and play, and mass will affect a resistance. It will give you a different plot. The size also, Imad, will affect it a lot. You see, I know a simulation is not something real, and it depends on the code you give the simulation. And the code basically, they implemented friction along X and friction along Y, and apparently friction is size dependent or surface area dependent. All right. So going back to your question, Priscilla, yes, the acceleration here is going to depend on mass, and given two objects of different masses, you're going to end up with different ranges, different heights, anything you want. Anyway, the portion about air resistance is just for you to have to think a bit, but whatever analysis you do in the lab report, it's going to be without air resistance, okay? The point is not to confuse you. It's only to give you some insight on how to start thinking. If you are blocked anywhere, let me know. I can sit with you and give you more hints. It's only that I'm trying not to give you answers, okay? Let me go back to my outline. We did what is projectile motion, kinematics, the velocity vector, range and height, air resistance. Now, I know you have a lot of unanswered questions. Let me show you the lab report and the manual. I think I had to close them, but I have them here. I had to restart my computer a few hours ago. It was updating and I freaked out. That's why all my windows are closed. So let me show you manual and lab report. 1 second, it's opening. So for you to know what to expect, I can simply click here. All right. You have some manual. It doesn't give you a lot. This states MA equals mg, and it makes sense because the net force is mg. Taken as absolute value, or you can simply say A is the negative term, or simply absolute value, yes. They show you the X equation as a function of time, and this is one of the kinematics equation, and they give you the height and the range. All right? Your job, okay, I will tell you about your job later. They show you some diagrams, some procedure. You will understand the procedure more when you watch the video that I'm gonna show you in a while. Okay, now the questions. Derive the equation of range and height. I gave you an idea on how to start. Let's say you don't know and you don't understand. You can watch the recording again, or you can simply read it in any book. How we find the equation of a range. Learn how to use it and derive it yourself. And yes, it has to be typed. And how do you type equations? You can insert equations. It's not difficult. Okay, if you don't know, ask me. If you believe, so this is the equation. If you believe this is time consuming, remember you have a week. Worst case, you do it on a paper and you type it the next day to feel less overwhelmed. I don't know. But I promise it's gonna get easier as you get used to it, okay? 2, for what launching angle would you expect a maximum range? Explain, you need to give a reason, you need to prove it, you need to theoretically discuss it. Which angle, you know, the shooting angle will give you a maximum range. Probably you know the answer, probably not. Think about it, yeah, but...
Yes, it's 45.
Yeah, but you need to prove it. Is there a way you can tell? A reason you can use mathematically to prove it? I don't know, think about it. Although those are very famous questions, like you can find them in any textbook and you can read about it, or you can think a bit about them. Now, I will be giving you 3 different launching velocities. And what I mean by that, the initial speed, the initial velocity. I think I'm gonna give you, I printed out those tables. I need to fill the results in and give you the results because you cannot do the experiments, I know. So you will be given different velocities. The velocity is gonna be increasing. This is the angle. So I'm gonna try 15 degrees, 25 degrees, 35 degrees, 45. You should know the error on the angle. The video can help you because I will show you in the video how I did the measurement, analog or digital measuring tool, and what is the smallest subdivision. The range is measured using a ruler. Yalla, stay with me a moment so I can show you the video. So also you need to know the uncertainty on it. I will do the measurements for you. So you will see that the range is gonna be different for different angles, and repeat again for a different or a stronger initial velocity and a stronger initial velocity. Now the question is, draw the 3 plots, range S as a function of phi, so y as a function of x on the same graph. Usually some students would ask, how do we do that on the same graph? Because they don't know how to use Excel. I want you to try it. Worst case, you can YouTube, how do we do that? You simply have to use X and the different Ys and select everything. Just a click. If you don't know, come back to me. Don't forget to add a title, to Google Sheets. You have Excel on Google Sheet. I mean by Excel, it has a different name, but it's the same app. Yes, of course you can do it. And Jane, when you finish, you take a screenshot, crop it well, insert in this lab report, okay? And don't forget, Jane and everyone else, to add a title, to label your axis. A lot of you do not know probably how to do that. So it's time for you to learn how to do this, all right? This lab is very easy. The physics is not complicated at all. So it's time for you to play around with the graphs. No data analysis is required in this lab. It's only that you need to know the uncertainty for phi and S, and that's it. No other calculation to do. Deduce the angle corresponding to the greatest range and compare it to your expected value in question 2. So everybody said 45. Did you get 45 experimentally? Draw a conclusion. No, examine the effect of launching velocity on different range. You can say probably when the velocity is stronger, the range is less or more or not changed. Whenever you want to come up with a conclusion, I would want you to go back to the theory because you have the equation for range, and go back to the experimental results. Because sometimes the results don't make sense. If you have a backup from the theory, you would know how to approach your experimental results by saying probably we have some errors, So always study the theory and the experimental data and draw a conclusion with some proof. And never say increase, like when we increase the velocity, the range increases. Try to say if it's proportional. Try to say V doubles, therefore the range doubles, or V increases by a factor of 1.2, so the range also increases by a factor of 1.2. Try to find constant or common factors or constant ratios. Don't say increase, okay? Just to make it more informative. What should you do to increase the range? So think about that. This is a conceptual question that is general. Sketch with air resistance, without air resistance. Write the new equation of motion. All right. Everybody will flip on this one. How do I write the new equation of motion? Equation of motion is already given in the kinematics equation. Here you have to do some assumptions. Do you want your air resistance to be along X or along Y? Is that Yara stealing chocolate? I think she is. It's okay, she can do it. All right, so back to you. So I was saying it's up to you to start with an assumption, which is I'm gonna take friction along X only, along Y only, along both, and the new equation of motion along X will become like this, along Y will become like this. Write what you think, all right? I don't wanna say it's an open question. It is actually an open question, and let me help you if you need help, okay? Now, lower your bench to the floor. Okay, so you're gonna read this later and you're gonna see my values later. Probably I can give you a quick sketch because some students don't understand this. This is where the gun is. This is the ground. And this is the table or the bench. It has some legs. Initially, you do the launching or the shooting like this. And you measure the range from the initial point to the landing point. Now they want you to put the bench on the floor. Putting the bench on the floor will not give you the range. It will give you only X, all right? So the gun is still the same, but now since the bench is on the floor, this is what is gonna happen. And you're gonna measure X being X, all right? And again, Y is not equal to 0 for this one because you are in the negative case. Remember, this is where your axis is. So Y is negative. So you measure X and you have the equation, which is, I'm not gonna tell you because the equation is very simple. Look at the equation relating X and V and T and try to answer the questions. All right? Now for the video, I'm gonna send you the YouTube link, but I have the actual movie. I think I'm going too fast. Do you guys have any questions? Are you still with me? That's the effect of an instructor talking nonstop. Students would die. Are you dead? All right. All right, I'm sorry because I was not stopping. All right, so Priscilla, you believe the lab report is confusing. Yeah, I totally feel you. So what you're gonna do is you're gonna watch the video slowly and try to start. You get confused, we meet, all right? What are the axes of the graph? You mean the plot? Are you talking about this graph, this plot? All right, I can
Yes,
see,
doctor.
Yeah, I can see that Christy is also confused. Yeah, I think the lab report is not confusing. I think I was confusing because I went over the whole thing in one shot. Yeah, it is a bit overwhelming. Yeah, I can see. So probably a week would help. So I really appreciate if you can call for help during the week. So I'm gonna leave you until next Monday, right? So how about we meet on Wednesday? Say it again. Sarah, I agree with you. Yeah, somebody was talking. معلش who? All right, so please let me know again. So basically they say, let me answer the question what to plot. They say range S as a function of phi. So this means we usually say y as a function of x. So this is your y, the range, and this is your x. So it's gonna be r versus phi. Okay, like this. You are given all the phi's and you are given all the r's. You need to plot them. All right. Is it time consuming? No, believe me, this lab report is the least time consuming lab report. I'm not saying that to freak you out. Remember, I will do the experiment for you. I will do the measurements. All you have to do is to plot and analyze. Yes, it takes time. That's why we give you a week to finish it. All right? And no, this is not time consuming. Expect other lab reports to have a lot of averages to calculate and RMS and linear regression and error on the slope. This has nothing, only a quick analysis that is conceptual. All right. When will we get the data? The data will be given to you this evening. All right. So which means Tuesday morning, you wake up with the data online. If you want, I can notify you when the data are on Blackboard. Now back to the video. I'm not gonna play it obviously because you will have the link. You can play it alone, but I'm gonna go over it quick, probably fast forward and pause a bit whenever I have to explain something. Okay. So this is the bench I'm talking about. Yes, the video, the link for the video will be on Blackboard. Yes, tell me, Andrew.
Sorry, before I was on Wi-Fi هلا 3G كان عم يعلق. المهم So basically بس تكون واضحة الفكرة بالوصف. بدي أحضر الفيديو with the PowerPoint وأفهم everything, and then the lab report is basically بس questions و answers. معك يعني it's like a quiz.
100%. So you just have to fill in the template. Please do not remove the questions. Keep the question, answer تحتها. Just for me to be able to understand.
طيب ماشي. Thank you.
All right. So that's your first trial. Let me assume that your first trial is not going to be a very serious trial. So worst case, I can expand the deadline for you. So this is not an exam. All right. It's a simple homework. Let's call it homework. I know it's graded, but yes, Saimad.
Finish doctor. أنا بس خلص حاجة بس question.
Yeah, you can interrupt me, no problem. We are a very small team here. All right, so I was saying, yes, I know it's a homework and I know it's graded, but you can resubmit again, you know. My students can always unsubmit and submit again. So you can always do something, show it to me, we can modify it. I know I cannot help you with everything, which means I will eventually give you hints and give you advice because I'm the one grading you. Imagine I'm giving you the answers and then I need to grade you. But I will definitely give you a push, all right? And I will tell you, I don't agree with this, repeat this part, especially for the first lab. I'm gonna be very flexible, okay? Don't freak out. Yes, you can submit several times. When I put the assignment on, I'm gonna say unlimited submissions. So, and I will only grade the last submission, which means all the submissions will have a grade similar to the last submission. All right, what to expect? So Andrew, you're gonna see on Blackboard under Projectile motion, the PowerPoint, the recorded session of today. You don't have the manual and the lab report in this section because I already gave it to you. Let me show you where, because you should know. So if you go to your class, all right, my screen is so small. All right, if you go to your class, you see announcement syllabus manual. So you have the whole copy of the manual. So I'm not gonna give you chapter 1 alone. And you go into the doc, save as only lab report number 1, and type on it. Save it as under your name, under a date, or simply call it lab 1 projectile motion. All right, so what you will see the PowerPoint edited, and let me know if you cannot see the edit because I'm writing on them. Probably you cannot see the writings. You will see a recorded link, the recorded session. You can see the actual experiment, the video of the experiment. You can see the results, and you can see an icon where you submit your lab report. All right, and you can email me if you need anything extra. I can add it to our folder. Is it individual work? I hope so, Yara, but again, you can work with one partner if you want, and this is optional, but please make sure you understand every single thing. If you don't have a partner, let me be your partner. I can help you somehow, okay? Cool. All right, so yes, you can work with someone. Now for the video, I was telling you this is a ruler. I'm gonna show you in a few minutes what is the smallest subdivision on this ruler. You can see the bench, it has a certain height. The height of the bench is supposedly the same height as the gun. From this side of the video, I can see they're basically not at the same height, or probably they are and it doesn't show. You can see on the bench, let me show you. Here I'm explaining. All right, so this is your system. It's a ball. It is actually heavy, the mass of which is not known. Since I'm assuming no air resistance, mass is not really needed. So basically, I show you the gun, how it functions. So you can change the angle of the gun. And this is a timer that would give you the initial velocity. Okay, for this video, I was kicked out of the lab. As you can see, I'm in a classroom. And you will hear a lot of echoes. I'm so sorry for this, but I had to do the experiment in a classroom. So again, I'm showing you how the launching is gonna happen. So on the bench, you have regular white papers, on top of which you have blue carbon paper that I'm sure you've never seen in your life. When I was a kid, we used to use this. It's like it gives you copies of what you're writing. Nowadays, you can scan using your smartphone, you can print. I don't know. So basically, the carbon paper, if you, yes, of course, you're talking about the video, right? Actually, if I widen the video, it's not gonna get wider because it's made with an iPhone. Even on YouTube, it's this thin. Are you talking about the video? Yes, Priscilla. Yes, even on YouTube, it's gonna be narrow because the phone was actually not used as landscape because I wanted you to see the whole thing, you know. But it's gonna move in I don't know. I know this would bother you, but I'm sorry for that. So back again to the blue carbon paper. If the ball will land on the blue carbon paper, the blue carbon paper will leave a blue mark underneath. This is the best way to see where the landing point is to be able to measure it. So now if I do the experiment, all right, so I'm showing how the landing is gonna happen. Here I'm showing you the gun again. I'm showing you the smallest subdivision and I'm talking about it. It could not be clear. And how I change the angle to 45 degrees. And here I'm showing you how I put the ball and how I use the spring to shoot the ball. All right. And this is and the different velocities, like this can go on 1, on 2, on 3, and eventually it will give you initial speeds that are bigger and smaller. This is the timer, or this is meter per second, by the way, so you can see 0.2 decimals. There's a reset button. I have to click on reset every time to zero it before I start. So probably I'm gonna show you one trial. All right, I just inserted the ball inside. I reset. All right, it switches off. Doesn't go to zero because I know this was not functioning. All right, I explain what is supposed to be. And here, this is where, so you can see you have another bench because I didn't want to lose the ball. So the ball will hit it because I don't have partners in this experiment to follow the ball. I do one experiment, probably it's gonna be fast, you won't be able to see it. So the ball, okay, let me play. And hopefully it will work. So I'm holding the way and I'm gonna release it. All right, so as you see, the ball is gonna jump. You will have many collisions. You're gonna take definitely the first landing, and I'm gonna remove the blue carbon paper to be able to see it. Probably I'm gonna do a mistake in this video, like look at some other thing, but I believe you will understand my point. All right, anyway, you see dots. I took this one. I think I should take the first one. But anyway, this experiment was done only for demonstration, not for the actual measurements. Here I'm showing you the ruler for you to know the smallest subdivision. The whole thing is 100 millimeters, which is 10 centimeters. So basically, you know what to expect. Yes. Yeah, so watch the video again. So here I'm showing you that I'm measuring from the launching, not from the beginning of the table, like from the launching here to the landing. fine. Yeah, I hope the video was informative. It's only to show you the procedure, not really to give you measurements. But from the video, take all the smallest subdivision of your different measuring tools. All right. I think that's it. And I think I shouldn't overwhelm you today with data analysis number 2. Where's our plan here? Because you're not gonna use it for the first lab. How about I give you a week to see how things are? Probably the next experiment will be, the routine will be a repetition for you, so it will be easier to approach. I don't know. Tell me what you think. Yeah, let me see. Ahmad, did you just raise your hand? Yes.
Yes دكتور, I need two clarifications. أول سؤال دكتور بخصوص projectile. هنا بالسؤال دكتور قالوا لنا إنه find a time and when the ball was in air. And which speed do we use ساعتها هون the initial or final?
All right, so you're asking a random question related to projectile. So you want the time taken for the ball or the projectile to go and land, right? So
Yes.
you're gonna
Yes,
take the
doctor.
final point, obviously. So it's the time to reach the final point, right?
Yes.
You take the final point, yes. And if you go back to the initial, to the kinematics equation, probably let me pick those because they look nicer. I want to find time. If you're sure you're landing on the ground, you can simply take y to be equal to 0 and find time. But if you're not sure you're landing on the ground, sometimes you have a mountain or something and you want to hit a certain height, point A. And point A usually has some coordinates, x and y. So you need either x
Yes.
or y to be able to find time simply using those equations.
Yes. ودكتور السؤال الثاني بس هو بالفيزيكس لا for example بالميديا اكزام أنا بيجينا مثل problems that you have to solve them أو بيجينا مثل analysis conceptual questions.
Okay, I need to answer this question in a general way because it depends. But basically, you should expect a lab report, a mini lab report, where we fill in the values and you do the calculations, the plots, the averages, the linear regression, the percentage differences, discuss the sources of errors, and all this. And you should expect some conceptual questions exactly like this question. Where is it? The question where they ask you what you should do to increase or draw a conclusion. What is the effect of the launching velocity? Like conceptual questions where the answer is basically not a value or a calculation, but something to discuss, proportional or not, sources of errors. So I'm going to call them conceptual questions and a lot of graph skills. You know, so expect data analysis like a mini lab report to analyze data, conceptual questions, graph skills. All right, but do not expect problem solving because we're leaving that for the course. Yes, is that it, Imad? Fadi is asking about the deadline.
Yes, doctor.
Okay, Imad. Fadi is asking for the deadline. It's gonna be before I see you, so it's gonna be Monday before 2:30. Do you think it's a good thing? Priscilla had a question, but as she's getting ready, I can answer Jane. Jane, no quizzes. Lab reports, 1 midterm, 1 final exam. All right? Yes, Priscilla, your question.
Doctor, can you hear me? My mic is working now?
Yes, it is working now.
Okay, I just wanted to ask, when you put the slide about air resistance and we discussed friction either along the x-axis or along the y-axis, I just didn't really get what did you want us to take out of this slide? Like, because you said you want us to think, so I just didn't know where to direct my thinking towards.
A very good question. And my bad probably. So the question in the lab report is to come up with the time equation.
Mm-hmm.
This and this, both are time equations. Let me show you the question again. They say write the equation of motion. Okay, back to the equation of motion, which is here. So we have an equation of motion along x, equation of motion along y. In some books, they call it equation of motion as r equal something I plus something j. But let's do x and y separately. It's easier for the eyes. So this, they want you to write a new equation of motion for x, a new equation of motion for y. And to be able to do so, we should go back to the general kinematics. We need to find the acceleration along x and the acceleration along y. If there's no air resistance, acceleration along x is 0, acceleration along y is negative g, and we can write those equations accordingly. What if I have air resistance? If I do have air resistance, now the acceleration along x is not 0, it is negative friction over m, right? So I'm actually here, I'm actually here. So the acceleration without air resistance is ax equals 0. With air resistance, it's negative friction over m. For the y acceleration, it was initially negative g. Now it is negative g plus friction over m. And if I change the equation of motions by simply putting, instead of acceleration, instead of a, I'm not gonna put negative g, I'm gonna put negative g plus friction over m. And for this one, I must add half at squared with a is negative friction over m. So basically you're done.
Okay. Okay.
So the reason
Doctor.
why I was discussing that is to show you basically what happens when we add friction. Basically, it's the net force that is gonna change. And I wanted to give you a starting point, how to start your analysis. But I did not want you to know where you will end up because I wanted to be an open question. And now that you know what the question and the lab report is, which is this one, probably you know more what I mean.
Okay, thank you.
All right, more questions. And again, please email me anytime, any day, any hour. And if I feel that my answer was not gonna be clear over email, we can meet for 10 minutes or 15. Do we assume friction to be constant? It's up to you, Fadi. You can say, I want to assume friction to be constant and call it F. Or you can say, I want friction to be speed dependent and call it, I don't know, constant times speed. You can say it's size dependent and call it anything you want. But since in the question they don't say anything, pick the easiest example. They say what happens if you have air resistance. They don't discuss it. All right, so start your problem, your answer by I assume this and that, and do whatever you want. By the way, I want you to be aware of something. This is a lab report, and the lab report is not like any homework given by the course. In other words, the lab report is always open-ended. It's like a piece of research you do. So your answer could be different than your friend, and you may be both right. It's your opinion, basically. You see? And I know you're not used to this. You're not used to open questions and writing what you think or what the results will be. And probably I'm gonna give you 2 sets of results, which means you pick a set and your answer is gonna be different than the team who picked a different set. You see? So I'm not sure, I did not decide yet how many sets of results I'm gonna give you and who will take what and if it's your choice or not. But anyway, I'm gonna give you results and this is what matters. Okay, so remember, this is research. This is something you write like a paper. It's not like in the course you solve and there's one answer. Okay, and you can convince me with any answer if you explain it well. You can say, in my opinion, this is the answer because this and that, and you can convince me, and your answer could be exactly the opposite as your friend. Yeah, so this is general analysis of something related to some measurements you are given. And trust me, if you are in the lab and you are doing the experiment, probably this is gonna be more, you will see more diversity because everybody will probably do the experiment differently and you will end up with different results and different analysis. And I love this. This is real life, it's real physics, it's real nature. It's not the ideal case you've been taught in the course. What you learn in the course is the ideal case, which is not real life, right? So there's one answer. Any more questions?
No, doctor, thank you.
All right, so I'm expecting questions on the email during the week. See you, enjoy your day. Of course, Ali, we can.
Thank you, doctor.
Bye, everyone.
Bye.
Bye.